Okay, I'm Tom Bryden. I'm going to be talking about my project, Off-Vehicle Energy Store Selection for a High-Rate Charging Station. Fast electric vehicle charging is needed to help overcome range anxiety of electric vehicle owners. Range anxiety being the worry of an electric vehicle owner that their battery will run out of energy before their destination is reached. The fastest current charging stations can charge electric vehicles at up to 120 kilowatts, providing up to 170 miles of range in half an hour. In the future, this charging power is likely to increase with the two main charging standards looking at increasing the charging power to 350 kilowatts. Therefore, fast charging stations require a high power grid connection, which limits the available installation locations and grid connection costs. In the future, as these powers increase and the number of EVs on the road also increases, meaning the charging stations are used more frequently, these problems are likely to be amplified. So the plan is, if you use a stationary off-vehicle energy store to buffer the power between the grid and the EV, the grid connection power can be controlled and minimized. As can be seen in this picture, in a conventional high-rate charging station, when an EV arrives to charge, power flows at a high rate from the grid to the electric vehicle. In the proposed design, power flows at a low rate from the grid, or when there's no EV charging, power flows at a low rate from the grid to the off-vehicle energy store. And then when an EV arrives to charge, power flows at a high rate from the off-vehicle energy store to the EV, and at a low rate from the grid to the EV. In this project, I aim to bring multiple aspects together, including future fast charging EV limits, likely fast charging usage patterns, grid connection costs, and the capabilities and costs of potential off-vehicle energy stores to determine the optimum type and size of off-vehicle energy store. To determine the future fast charging limits as well as capabilities and costs of potential off-vehicle energy stores, I will be performing experiments to characterize commercially available batteries at high charge and discharge rates. I'll work out the likely limits of the batteries. For example, is the high rate charging and discharging limited by the voltage, or by the heat generated, by the degradation, or by the efficiency? And to accomplish this, I've just finished setting up some high power charging and discharging equipment in the lab to take the batteries to their limits and hopefully get some interesting results. Thank you.
Questions at all, anyone? Somebody? Oh, Elaine's got
Very interesting, Tom. The sort of the architecture, the approach there isn't too dissimilar to what's used for gas refueling for heavy-duty vehicles. Do you think it would be helpful to look at some of the approaches they've used to help size, say, buffer tanks and connection rates to sort of give an understanding about the economics behind the approach?
Oh yeah, definitely. I'm hoping to involve a lot of economics in the modelling. So when I bring all the aspects together, economics will be a key factor. I haven't come across that, but with the gas refuel, but yeah, that would definitely be something I can look at. Thanks.